Hi class, this is Dr. Karsten, and today I am going to be going over Lesson 6 from Module 5, Grade 4. So in today's lesson, I'm going to be doing it a little bit differently than it is in the book, so you have to pay really close attention to how I'm doing it, because I'm really going to focus in on the main idea and the important parts of this, and I want you to do it the way that I'm going to show you when you are doing your homework. So Lesson 6 is very similar to Lesson 5. In Lesson 5, we were taking unit fractions and we were decomposing them or pulling them apart into smaller pieces to show equivalent fractions. In today's lesson, we're going to be using different kind of fractions, we're not going to limit ourselves to the unit fractions anymore. So as a quick review, let's take a look at a problem that would have been kind of typical on yesterday's. So here you can see that I have this diagram done for us, a model, and I have it broken up into 3 parts. So that should tell you straight off the bat that we have a denominator of 3 because again, the denominator tells us how many pieces one whole has been divided up or split into, how many parts, how many segments. So in this case, I would know that my denominator for the original problem would be a 3. So I'm going to write that right here for us. Now, as you can see, one of those pieces is shaded in, so I have one piece. So that's what I'm going to write in the numerator. And so now what you can see is that this represents 1/3 of the whole thing. Now, in yesterday's lesson, what we did was we decided what we wanted to turn these into. So for now, let's keep it simple. And let's say that I want to turn that 1/3 into 6. And so what we decided to do is we said, well, what would I have to multiply 3 times to turn it into 6? What would I have to do? I would have to multiply that by 2. And another way to think about that is to say 6 divided by 3 would give me 2. And that was a little kind of thing that I showed you. So what I'm going to do is now I know I need to split this up, each one of these, into 2 pieces. And so what we did was we drew a horizontal line to split this up. So now each one of these pieces has been divided into 2 pieces. Now what I've done is I've turned this entire thing, this entire model, into 6. Here you can see I have 1, 2, 3, 4, 5, 6 pieces. So my new denominator is 6, and you can see that now I have 2 parts shaded in. So I'm going to go ahead and put a 2 there. So what I just showed you was that I turned 1/3 into 2/6, and that they are actually the same thing. I haven't shaded anything else. Nothing has changed other than how many pieces I cut this up into. Think of a chocolate bar. First I was going to share it with 3 friends. Now I want to share it with 2 friends, or with 6 friends. So now you get the idea is that you're just kind of taking the same piece and you're dividing it into more pieces. Okay. The other thing that we did yesterday was that we did number sentences. So we said, for example, that 1/3 is equal to, and we wanted to turn it into 6s, and what we had to do is we could say that it would be equal to 2/6. So it would be 2 times 1/6. And that gives you 2/6. And that shows you that 1/3 is equivalent to 2/6. Another thing you could have said was that I had that 1/3 is equal to 1/6 plus 1/6, which is equal to 2/6. And since I was adding 1/6 2 times, it's going to be 2 times 1/6. So that's all the ways that we did it yesterday with a unit fraction. Now let's try it with something that's a little different from a unit fraction. So in this case, I again have my one whole item here, my one model, that's going to represent one whole. But now, again, well, let's start with what's the same. Again, it's divided up into thirds. So I'm going to go ahead and put a 3 in the denominator for the 1, 2, 3 pieces. But this time, instead of having just one piece shaded, I have 2 pieces shaded. So I'm going to put a 2 in the numerator. Again, denominator is the number of pieces that the whole thing has been cut up into or split into. And the numerator is the number of pieces that you have or that have been shaded. So now for this one, I again want to turn it into 6. So I'm going to have 2/3, and I want to turn it into 6. So again, I have to think about what would I have to multiply 3 by to turn it into 6? Or 6 divided by 3 is going to give me what number? Just doing the inverse operation. Now we already know this answer because we did it above, so I can go ahead and write times 2. So I now know that I am going to have to cut each of these pieces in half. So I'm going to do that again. I'm going to divide them in half. So now again, just like in the above example, I have a total of 6 pieces. 1, 2, 3, 4, 5, 6, or 6 parts, 6 segments. So I'm going to make that my new denominator. But this time I have 1, 2, 3, 4 pieces that are shaded in. So now I've just shown you that 2/3 is the same thing as 4/6. I didn't change what part was shaded in out of the whole. It's still the same. I just cut those pieces into smaller pieces. Okay, so now again, let's take a look at how we could write this in a number sentence. So the first thing I could do is I could say that 2/3 is equal to, and I could take a look and say it's 1/6 plus another 6 plus another 6 plus another 6. I could write that 4 times. So 1/6 plus 1/6 plus 1/6 plus 1/6, and that's going to be 1, 2, 3, 4, 6. Remember, when you're adding fractions that have the same denominator, you just can add the numerators together and keep your denominator. And we can see that here. I have 1, 2, 3, 4, 6. Now, I added 1/6 4 times. So again, I could have just said 4 times 1/6. And so now I can say that 2/3 is equal to 4 times 1/6, because I added it 4 times. And that's equal to 4/6. So this is the gist, or the main idea, of what we're going to be doing today. And I wanted to show you a complete fraction on the paper here, because there's really not a lot of problems in the problem set, which is, I know, a nice relief for you when you're doing your work at home. So let's go right into the problem. We are definitely, without a doubt, going to skip 1A because it has all this other stuff. Maybe at the end I'll go back and show it for anyone who's curious about why it's that way, but for now I want us to do it the way that I just modeled it, so let's go into 1B and take a look at it there. So let me get rid of that 1A completely. So what the problem is asking us to do is first we have to figure out what is this original fraction, and we're going to put it up here. And then it tells us here that we have to turn it into tenths. And then we want to show some number sentences to show the relationship between whatever this fraction is and whatever this fraction is. And again, we're going to do it just like I showed you in the first problem that I did. So the first thing I have to do is I have to figure out what is this original fraction. So I'm going to take a look and see what has this whole been cut up into. How many pieces is it? How many pieces make up the whole? That's going to give me my denominator. And if I look at this, I can see that there are 1, 2, 3, 4, 5 pieces in this entire thing. So I'm going to put a 5 in my denominator. Now I have to figure out my numerator. And again, the numerator is the number of pieces we have, which would be the same thing as saying the number of pieces that are shaded in. So in this case, 2 pieces are shaded in. So I'm going to go ahead and put a 2 there. So now we have to figure out how am I going to turn this 2/5 into tenths. So I'm going to write that up here. So I have 2/5, and I want to turn that into tenths. And just like we were doing before, what would I have to multiply 5 by to turn it into 10? What do I have to do? Or you can do the inverse. So instead of saying 5 times a number equals 10, I can say 10 divided by 5 is equal to that number. Same thing. And if I do it this way, and if you have to do it on a separate piece of paper, that's fine, but what you should get is 2 for all of these. So now, since I see that it's 2, that's telling me that I have to cut each one of these up into 2 pieces. I have to divide them in half. So I'm going to go ahead and do that by drawing this line across. So now I've cut each one of these up into 2 pieces. I've made them into smaller pieces. So now, for our new fraction down here, let's figure out what our denominator is going to be. Again, it's the number of pieces that make up the whole, so let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh good, we got tenths, perfect. So my new denominator is 10. Now my numerator is the number that I have, it's the number of pieces we have, or parts that we have, or it's the number of shaded pieces, because that's how we represent what we have. And in this case, we have 1, 2, 3, 4. So now I know that 2/5 is equivalent or equal to 4/10. It's just a different way of cutting it up. Okay, so now though we have to get into the slightly trickier part, which are those number sentences. So again, we are not doing it the way they did it on the top. We are doing it a little simpler, a little more clear for our purposes. So if I take 2/5, which was the original fraction, I need to show what this was equal to in tenths. And what I can do is I can say that 2/5 is the same thing as 1/10 plus 1/10 plus 1/10 plus 1/10. So let me show that. So it's going to be 1/10 plus 1/10 plus 1/10 plus 1/10, which we already know is equal to 4/10. But now I want to show that using multiplication. So what I'm going to show for this one is I'm going to say again my original equation 2/5 is equal to, and now I have to take a look at this. How many times did we add 1/10? I added it 1, 2, 3, 4 times. So I'm going to write 4 times 1/10. And we've been doing this. We did this all over the place in Module 4. So you should be familiar with turning an addition sentence into multiplication. Okay, so now I can just set that equal to 4/10. And again, when we multiply a fraction times a whole number, we can just multiply across the top. 4 times 1 is 4. And then we can keep our 10 because really this 4 is like 4 over 1. I just want to show you guys that. I can put that 4 over 1 and do that. So that's a little shortcut. So this is the idea of what we're doing, and I do want you to try the next problem, which is problem C, on your own. And just remember as a hint, and I'm going to show you another problem in 2, but I just want to remind you that for this, first you're going to find the original equation, then you have to figure out how are you going to turn fourths into twelfths. I'm going to give you guys a little hint over here. So just remember, if I want to turn 4 into twelfths, so I'm not going to go ahead and do this. 4 times what number is equal to 12, or 12 divided by 4 should give you that number. So that's your only hint that I'm going to give you for that one. All right, let's take a look at problem number 2. So problem number 2 is basically going to be a very similar problem, except for we are going to be drawing the area models ourselves, or drawing the models ourselves. Okay, so let's take a look at this problem. Now, like I said, it's basically going to be the same thing. We are going to be taking the original fraction, which is 3/5, and turning it into 6/10. And they were nice. They told us what we're doing already. So the first thing I have to do is draw my model. So I'm going to give myself a decent-sized box here to work with. Leave a little room on the top and the bottom. And I can see that I have to start with fifths. So I'm going to give myself a little room. And then I have to model 3/5 in this. So since my denominator is 5, I know that I have to divide this into 5 equally sized pieces, or as equal as I can get them. So I'm going to go ahead and try. I think I'm taking a little risk doing this with my pen. All right, I'm going to take that. That's pretty good. Now that covers my denominator. My denominator is the number of pieces that make up the whole. I have 5, 1, 2, 3, 4, 5. Now I have to deal with the numerator, and the numerator for this one is 3. So I need to shade in 3 of these pieces. So I'm going to go ahead and shade in the first 3 pieces. And try and do a good job, a reasonably good job. All right, so I have just modeled 3/5. I'm going to go ahead and bracket that off. Now I have to turn that 3/5 into 6/10. So let's think about how we're going to do that. If I need to turn 3/5 into tenths, what am I going to have to do? 5 times what number is 10? Or vice versa, 10 divided by what number gives me 5? What am I going to do? And again, I can write that on the side. 5 times some number gives me 10, or the inverse, 10 divided by 5 is going to give me my number. And if you do this, you will realize that 10 divided by 5 gives you 2. So again, I'm going to have to split this into 2 pieces each. So I'm going to have to just divide it in half. So I'm going to go ahead and do that. So I divide it in half, and now I have tenths. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now my new denominator is 10. Trying not to go in the way of that problem. And my new numerator, so the number of pieces I have, the number of shaded pieces, is 1, 2, 3, 4, 5, 6. So now I have 6 tenths. So now I have just modeled that 3/5 is equal or equivalent to 6 tenths. Now we have to do the number sentences to show the relationships. And again, I want to keep it simple the way that I've been doing it with you. So let's start. We already have this written down. We have that 3/5 is equal to 6 tenths. So I'm just going to work underneath that. But if I hadn't done this right here, you would have written this. So the first thing that I want to show is how I could add all of these parts up to get 3/5. So 3/5 is equal to, and these are all tenths, so this is 1 tenth, 2 tenths, 3 tenths, 4 tenths, 5 tenths, 6 tenths. So let me model that. 1, 2 tenths, 3 tenths, 4 tenths, 5 tenths, 6 tenths. So I can set that equal to 6 tenths. Now again, I also want to use a multiplication sentence. So I'm going to show again that I started with 3/5, and I want to show that that's equal to 6 tenths by using multiplication this time. So since I added 1 tenth, 1, 2, 3, 4, 5, 6 times, I can write 6 times 1 tenth. And when you do that, 6 times 1 is 6. And then again, the 6 would just be over 1, so it's 1 times 10 is 10. And we already knew that from the problem anyway. This is how I want you to do this problem. So your homework is going to be to finish out problem 1 by doing 1C, and then you're going to do 2B. I am not asking you to do problem C. So this is going to be a nice, easy day for you. Problem 3. This is going to be a nice, easy homework for you, so a nice little catch-up for us. Now, for those of you who are curious, and if you are not curious and you don't want to get confused by what I'm going to explain, then walk away and turn me off. But if you are kind of curious about problem number 1, I'm going to give you a super duper quick explanation of what they're doing here and why they have parentheses. The reason they have these parentheses off is because what they're doing is they are showing you that from your original problem, you had 1/3 and you had 1/3, and they are showing them to you separately. So instead of just doing like we would have done 1/6 plus 1/6 plus 1/6 plus 1/6, they are grouping it, and they're saying this 1/3 is made up of 1/6 and 1/6, so that's this. And then over here they're showing you that this 1/3 was split up into 1/6 and 1/6. That's why they have these parentheses. We're not doing that. Keep it simple. We are going to stick with the way I just showed you, so hopefully that didn't confuse you. I warned you to turn me off if it was going to. So I hope you all have a great night, and I will see you bright and early tomorrow morning in our Google Classroom. Have a great night, everybody.